Good morning. Today we are going to be covering section 10.5, which is finding the area of circles and sectors of the circle. So the first thing we want to revisit is our area formula for circles. Area is going to be equal to pi times our radius squared, where our A represents our area value and the R is the radius. So again, we want to make sure that we know how to identify these items on our circle. Again, here's our circle, and the radius is the distance from the center to a point on the circle. So that value right there is our radius. When we're talking specifically about area, we're talking about the inside of the circle. So all of this green, that's what we're looking for. And that green, that inside space, is called the area. Let's go ahead and look at two examples. The first one, what is the approximate area of a circle with a diameter of 12 centimeters? Again, I'm going to write down my formula. I like to use that as a guide as I walk through these steps. So we need, in order to calculate area, we need radius. In our example, we're given a diameter. If I know the diameter of anything, of the circle, then I know that the diameter is equal to 2 times the radius. So I'm going to calculate my radius real quick here. It's just going to be half of 12. So I'm going to write 12 equals 2r, and I know that my radius is now 6. Now that I've found that value, that's 6, I can plug that into my formula. So area is equal to pi times 6 squared, which is 36 pi centimeters squared. In the second example, we're given the area. Here's my area. The area of the circle is 49 pi. What is my radius? So we're kind of working in reverse here. But again, if you're able to write down the formula, area is equal to pi r squared, and substitute the given value. In this scenario, it's area that we were given. So we're going to write 49 pi is equal to pi r squared. Step 1, I'm going to divide out my pi. I'm left with radius squared is equal to 49. How do I undo a square? Well, you take the square root. So the radius is equal to 7 inches. Moving on to the next section, we want to look at area of a sector. And here this definition for area of a sector is very important. So a sector of the region of a circle is the region bounded by 2 radii and the arc between the endpoints of the radii. So again, your sectors can look like a piece of pie, a very large piece of pie, like these two examples, or a very tiny piece of pie, like this example here. And this shape almost looks like the entire pie with one slice missing. So those are sectors. And we want to take a look at how do we calculate the area of that sector. So again, we have area. We're looking at a circle shape. So we know we need to use the area of a circle formula. But if you notice, we're only given a portion of that. So then we want to refer to the fact that circles are 360 degrees. So here is our formula for that. So the area is found by taking the central angle given, or the arc, over 360 times our area formula, pi r squared. Again, A is area. A with the degree sign is the measure of the arc. And again, the measure of the arc is able to be calculated if we're given a central angle, because central angles and their arcs have the same measure. And then the r is the radius. So let me show you an example of what that could potentially look like. So here's my circle. Here's my radius. And I want to be finding this arc or this sector right here. In that scenario, I need to know also the measure of the arc, which would be congruent to the central angle because it is formed by a central angle, 2 radii. In example 1, we are looking to find the area of the shaded region. Again, I highly recommend writing out the formula. So arc over 360 times pi r squared. In this scenario, we are given the central angle of 210. Therefore, my arc is 210 degrees. Times pi times radius. Here's my radius, which is 18 squared. Now, there's many ways that you can do this. I highly recommend you just going ahead and using your calculator. I'm going to go ahead and multiply 210 times 18 squared for just my numerator portion here. I'm not going to include my pi because I know I can leave my answers in terms of pi. So just that basic multiplication up there gave me 68,040 pi over 360. And my last step is to divide by 360 to simplify my answer. So I get that my area of that sector is 189 pi units squared. Go ahead and take the time to make sure that you can enter that properly into your calculator. All right, moving on to the next example. It says the area of a sector is 8 pi and the radius of the circle is 12. What is the central angle? Again, writing out my formula is super important. Now that I have it written, I'm going to plug in the information that I was given. So we're told that the area is 8 pi. So I'm going to go ahead and substitute there. 8 pi is equal to, again, the angle we're looking for that, the arc measure, times. And then we're told here that our radius is 12. So here's our radius. We're going to plug in 12 there. Again, now we're going to just rely on our algebra properties to do some simplification. It's really up to you how you want to do this. I'm going to tell you what I get once I do the simplifying. So I'm going to go ahead and simplify on the right side here. I get 144 pi 60. I'm going to multiply by 360 on both sides. Lots of algebra, lots of stuff happening on this side here. So just be careful with your process. Just trying to walk through this so that you guys can see what I'm doing. And when I do that division, I find out that A is equal to 20 degrees. So that's my arc, therefore my central angle, A is 20 degrees. All right, the last portion of our notes is finding the area of a segment, the area of a circle that is bounded by a chord and an arc in the same, with the same endpoints as a chord. So what does that really look like? So we are going to be in a situation where we potentially have a circle like this. We have its center, and perhaps we're looking here. Here's a chord, right? It doesn't pass through the center at all. It just goes from one end of the circumference to another. And we're looking for this part in here. Could be something as small as that. Otherwise, we could have another circle here with its center, and it could look like this. Lots of examples that we're going to be analyzing and trying to figure out. So here is the basic formula that we're going to be looking at. Again, we're going to be using our area of sector that we just used. So area is equal to that our arc over 360 times pi r squared. And then here's key. We're either going to add or we're going to subtract the area of a triangle. So base times height divided by 2. Let me go ahead again, identify what my variables represent. So this is the measure of the arc. R is our radius. A will always be our area, capital A. And then this is our area of a triangle formula, so base and height. Again, this part, this component right here, this plus or minus is key, depending on what we're looking at. So if the segment that we're looking at is small in this scenario, we're going to be subtracting the area of a triangle. Whereas this scenario here, we're adding on the area of the triangle. So be careful with that as you analyze some things. Looking at the first example there, it says, what is the area of the shaded region to the right? So I'm looking at my circle. I know I have to use this formula that I've been given. And I'm noticing that the segment that we're looking at is very small. So I know that as I write it out, I will be subtracting the area of a triangle. I'm going to go ahead and plug in all of the information that I know. Here we're being asked for the arc. Well, here's the central angle, so the arc is going to be equal to 90 times pi. And then my radius is 8 squared minus, now the area of my triangle. Here we're looking at this triangle right here. This distance is my radius, and the radius is the same no matter what. So now I have the base and the height of my triangle. So I'm going to subtract out 8 times 8 divided by 2. Again, you want to go ahead and use your calculator to do this work. I'm going to go ahead and do it. 16 pi minus 32. And then we're talking about centimeters squared. Go ahead and check yourself these answers. Don't just copy it down so that you have an idea of exactly what we're doing and how I'm getting those values. So in the second scenario, we're given some information and we're going to be working backwards a little bit to find the radius. So again, I'm going to write my equation here, my formula. So the arc over 360 times pi r squared. And notice how that segment is more like an area of a sector at this point. So area of a sector, I just need to know that. I was told that the area is 60 pi. The angle is 24, therefore my arc is also 24. And I'm going to be solving for my radius squared. So I'm going to multiply both sides by 360 to eliminate that denominator real quick. Okay, then I'm going to divide by 24 pi. Once I do that, I get my radius squared equal to 900. Last step is to get rid of that square by taking the square root. And I find out that my radius is 30 units. Okay, that is the end. Again, make sure you use your calculator to verify my values. And if you have any questions, please feel free to reach out to one of us.